Okay, let's get started then with worksheet 4A. We're going to use many of the skills that we have been working on over the past couple weeks, coming up with equations and expressions, evaluating them, getting our data to plot points on a graph, finding our intervals, and so forth. So this past summer, you were hired to work a custom t-shirt shop called US Shirts. One of your responsibilities is to find the total cost of customers' orders. The shop charges $8 per shirt plus a one-time charge of $15 to set up the t-shirt design. Okay, so $8 per shirt and then plus a one-time charge of $15. So how does the problem situation differ from last week's problem? Use a complete sentence. So it actually was kind of like maybe 2 weeks ago. But remember when we were doing our hourly, we were working hourly? And we were making our graphs? What's different here? And this has been a little while actually because of our days off and stuff. So why don't I just kind of refresh us? Remember the last time we were working on our expressions and coming up with our graphs, we were working on those problems of $9 an hour or $7 an hour. So all we had at that point was sort of one piece of information. In this problem, we have two things. We have the $8 per shirt plus the one-time fee. So not only are we going to be multiplying, but we have the plus we're going to also be adding. Okay? So the difference here is adding the one-time fee. Okay, so everyone can be copying now. So let's start number 2 together. Let's set this up using an expression, showing our work, and nice and organized. Okay, so what's the cost for ordering 3 shirts? Well, how much is it per shirt, everybody? $8. So we're going to take that $8 and multiply it by the 3 shirts. But then what don't we have to forget about? What did we just write in number 1? That one-time fee. So then we have to plus add the one-time fee of $15. Order of operations, multiply first. 8 times 3 is 24. And then 24 plus 15 is 39. Use a complete sentence to answer that. So this is where some of you guys are falling short. Make sure you're telling us what this 39 means. So it will cost $39 for 3 shirts. Any questions so far? All right, go ahead and do numbers 3 and 4. And those of you that go fast, go ahead and work on 5 as well. Remember on 5, when you're explaining, I don't want to see numbers. You're using words. Okay, so go ahead. 3, 4, and 5. Don't move on after that. Let's check our answers first. All right, good job for those that have participated and finished. You guys look great. So let's do number 3 and 4 out just to confirm everyone knows what they're doing. On number 3, we're looking for 10 shirts. So we're going to use the same similar process, but it's going to be 8 times 10. So notice what's in parentheses is what changed. Everything else stayed the same. What is that called, guys, when I say something is changing versus something is staying the same? What do we call that in math? A value that changes. Does anyone at home know? Versus a value that stays the same. Think about some questions we've had in the past. Something that changes or something that stays the same. variable, and constants. Okay, what's changing is our variable. So 3 and now 10. The number of shirts is changing. So that'll be a variable. The 8 and the 15 is staying the same. So we call those a constant. Okay, keep that in mind as we continue. So we get 95 for number 3, like most of you said. So it will cost $95 for 10 shirts. And then for number 4, keeping that 8, that's constant. The amount per shirt is constant. The number of shirts is a variable. It's changing, plus the constant one-time fee. So we get 800 plus 15, 815. So it will cost $815 for 100 shirts. Okay. Does anyone want to tell us how they came up with their sentence? Anyone feeling confident and willing to share? Anyone at home? All right. I'm going to call on people to do different parts. So the first thing we did is what operation? I'm just going to randomly pull from the paper here. Ashley, what's the first operation we did each time with our calculations?
Multiplying.
Exactly. Okay, so I multiplied, and what we need to come up with is what we multiplied. We multiplied the 8 each time. What does 8 represent? The cost of a shirt. By, then it was 3, 10, and 100. That changed. That was the number of shirts. And then, Alyssa, what did we do next after we multiplied?
We added.
Good. Perfect. We added the one-time fee. One-time shipping fee, even. Okay, so notice there, I don't see any numbers. I'm using vocabulary words of operations, multiplied and added, and then using words to describe those numbers. Cost of shirt, number of shirts, one-time fee. Okay, once you have that, you can flip it on over. Is everyone good for me to move this? Everybody at home, just let me know if I move things too fast. Just let me know. Okay? So now we are on number 6. This time they're telling me a customer has $47 to spend. How many shirts can I buy? So what are we going to do here?
You can just divide 47 divided by 8, and then you have to do the 15 here.
So Jordan is saying some really great things. He's talking about dividing by 8. And then he's also saying we have to remember about the 15.
And we subtract first.
Bingo. You two have combined this perfectly. Okay? So Jordan and Jake, good job so far. Winners for today. And what we're doing is the opposite of what we were just doing, right? This time around, we have the money. We're looking for the number of shirts. So we're undoing our operations. So that's why we are dividing, and that's why we are subtracting instead of multiplying and adding. But remember, we have to do it as the opposite of order of operations. So yes, we're going to subtract. So I'm going to kind of give you guys a hint for probably a question that's to come in the future. But remember before we had 8 times the number of shirts. This time around, we don't know those shirts. So that's our variable. It's unknown. So I'm going to put an X there. And then we were always adding our one-time fee, and that gave us the total amount of money or the cost, which for this time around we know is 47. So this time around, instead of an expression, I'm going to use an equation. And how do I solve this equation? The first thing will be to do, like Jake said, is to subtract. Now we have 8x. The 15s cancel. 47 minus 15 is 32. And how do I undo 8 times x? Just like Jordan said, I need to divide by 8. So x equals 4. So what does that 4 represent? The question is how many shirts? So we can buy 4 shirts with $47. Okay, so before I was looking for the cost, so that's why we did the operations that we did then. Now I know the cost, so we're undoing all those operations. All right, go ahead. Do 7 and 8 like we just did with 6. You can certainly use a calculator for this. We'll go over 8. So for number 7, the correct answer for 7 is 25. So let's do that one, okay? We know each shirt is $8. We do not know how many shirts, so we'll have X again. And then we have our one-time fee, and that total cost this time around can equal up to $215. That's how much money we have. Okay, we will subtract 15 from both sides of our equation. 8x equals 200. And then we undo multiplication with division. And that gives us 200 divided by 8 is 25. So we can buy 25 shirts with the $215. Okay? Does anyone have questions with number 7? Are we all comfortable there? All right, I'll leave that still on the screen for you, but let's go into number 8. Similar setup, right? $8 per shirt. We don't know how many shirts, so it's X. Plus there's always the one-time fee, and we have $925 to spend. So just like the others, we're going to subtract our 15. We get 8x equals 910. From there, we divide both sides by 8. This gives me 113.75. So a few of you guys got that. Some of you, I think, probably had it, but we're a little uncertain that you did it right. But that is the correct value. However, that's not what we want to put in our sentence. Can you have a quarter of a shirt? No, that's not possible. If this was money, no problem to have decimals, right? We can say 75 cents. But this is talking about shirts. So if I have 113 and 3/4 of a shirt, how many whole shirts do I actually have that I could purchase? 113, exactly. Even though rounding rules, okay, and I see in the chat, even though rounding rules would say bump that up, remember, with $925, it's not getting us to that 114. It's only getting us to 113 and 3/4. We don't have extra money to spend to get to that 114. So we have to round down, and we only actually have 113 whole amount of shirts. Okay? So that's for the sentence. We want to say we can buy 113 shirts with $925. Okay? So X technically is 113.75, but in terms of understanding in real life, we'd really say 113. So now with our complete sentence, I'll do this one just to save a little time, but again, I start to see this on your papers that you're submitting. What operation are we doing first this time? We're subtracting. So first, I subtract the 15, but I don't want to say 15. 15 represents the one-time fee. And we're subtracting it from 925, which is the amount of money you have to spend. So I subtract the one-time fee from the total amount of money. And then after we subtracted, we divided. And oopsies, sorry, eraser. And then divided by 8, but I don't want to say by 8. What does 8 represent? Good. The cost of each shirt. Okay, so again, no numbers there, all descriptive words. Any questions? Once you have that, you can slide on to the next page. Is everybody good at home and in the classroom for me to slide this? Just say no if not. Okay, so number 10, we don't really have any work to do besides fill things in. But let's talk about this, and I hope everybody is listening right now instead of jumping ahead. This table is going to be super important for work that we do. Well, I won't see you guys tomorrow. You guys have the day off for Thursday. Okay? So we need to make sure we have this table correct. But again, don't put any numbers in right now. I want you all to be listening. This first column, what does this first column represent in terms of a variable or in terms of a graph when I get there? What? Very good, Jordan. You're on a roll today. This represents our X variable. Okay? Remember before I was saying variables and constants? Variables were what was changing. We had 3 shirts. Then we had 10 shirts. Then we had 100 shirts. And look at what this label is, the number of shirts. Okay? So our first variable is our X variable, which was the number of shirts. Then what else changed? The total cost changed. That is our Y variable. Okay? So please keep that in mind when we're talking about variables, is we have our X variable and our Y variable. Then we have our constants that we'll discuss later. Okay? So now what I'm going to have you do is go back to the calculations we found and plug the missing values in. So when there was 3 shirts, how much did that cost us? Someone. What? For 3 shirts? 39. Good. Okay, then vice versa. There's 47 for our cost. What number of shirts went with 47? Again, this is all from the calculations we did. 4. Good. Does everyone see where we're getting these? Okay, right? 47. I'm just going to scroll. 47 was right here from question 6. 47 shirts. We found $47. We found 4 shirts. Then we had the 10 shirts. 10 shirts came from the first page. Number 3, for 10 shirts, it was $95. So I'm going to put a 95 next to the 10. And we keep using our data. For $215, we were able to get 25 shirts. From the first page, when it was 100 shirts, it cost us $815. Now, what am I going to put next to the 925?
113.
Do we all agree? Here's the trick. What is this first column representing? It's representing X. What did we say X actually equaled on that problem? What did I circle for X? I actually circled 113.75. In terms of actually stating your answer, though, of real life, we'd just say 113. Here's the reason, guys, I'm having you write 113.75 is because when we have our X and our Y, when we plot our points, we need to make sure it's exact and linear. If we start rounding, our line will not be straight anymore. It'll start to curve a little bit. We don't want that happening, okay? So when I looked at that problem, I want to see in a sentence, this means we can only buy 113 shirts. But in terms of your X and your Y solution, the ordered pair is 113.75, comma 925. All right, and the last problem is one that you have to do on your own, and then we're going to go to lunch. So because we didn't do this one, I don't think, right? So for 150 shirts, what would I do as my calculation? Who can lead us? We'll put it right here. What would we multiply? 8 times 150, and then don't forget to add the one-time fee. So 8 times 150 is 1,200 plus 15, 1 second, is 1,215. So that last column can have 1,215. Okay? So please make sure you have this chart copied exactly correctly, and then you may head off to lunch. We'll see you guys in a little bit.